Hello and namaskar, everybody. It's me, Deepak Rajbhat. I'm a physics student uh, of the Central Department Physics in Kirtipur, Tribhuvan University. I'm a 77 batch student. This is my roll number, and this is my contact number, and this is the address, email address for email to me. And today I'm going to do the virtual lab on the topics of determination of the refractive index of a thin glass plate by Michelson interferometer. And I'm going to submit this my virtual lab to the Central Department of Physics of our HOD of Tribhuvan University of our department. On these topics, it belongs to following content: aim of the experiment, abstract, keyword, apparatus required, introduction, literature review, and their corresponding pages. Similarly, literature theory, methodology, observation, procedure for real lab, advantage of the virtual experiment, limitation, as well as precaution, result, conclusion, acknowledgment, reference, and appendix. At first, aim of the experiment. The main of the experiment is to calculate the refractive index of a given glass plate, and it is also help to in this virtual lab experiment also help to calculate the wavelength of a given source of light, such as our helium neon laser light, wavelength of the helium neon laser light, and the krypton laser wavelength of the krypton laser light, as well as for other purposes. Michelson interferometer meter is a historically important device which provides the simple interferometric configuration for introducing the basic principle. This device work under the principle of interference. Michelson interferometer can be used to find out the refractive index, as well as it is also used in OCT, optical coherence tomography, as well as in the field of atmospheric and space application. In OCT, it is mainly used for medical purpose, for medical imaging techniques. And the second one, the content of this virtual lab is our abstract. Abstract of the Michelson interferometer is to measure the refractive index of a helium neon laser light, as well as this experiment completed within the 4 different sub-experiment that measure and observe the properties of the incident light. First, we used a helium neon laser to calculate the wavelength, and after that we calculate the refractive index. Nearly I found 546.3 nanometer, in the range of nanometer, 5,000 I found 5,463 angstrom of the given laser light. Means the wavelength of the given laser light is nearly this. And after substituting this value, finally I get nearly 1.5 refractive index of the given glass, which is closely related to our approximation value, or the experimental value of the refractive index of a glass. And the next content of the experiment is the keywords. Keywords belongs to flowing words: light source, polarization, and next image resolution, microscope, spatial coherence, scattering, interferometer, glass diffraction, interference, monochromatic, and MMI, which means Michelson-Morley interferometer. And next one is OCT, means optical coherence tomography. These are the keyword which belongs to our this experiment. Next content of my experiment is apparatus required. For conducting this experiment, we need the flowing uh, we need the flowing uh, apparatus. First one is Michelson interferometer, which looks like this, and the second one is our self-container laser source, which look like this. This is our self laser source. Maybe it is helium neon or krypton. And next one is our aluminum plate, means pinhole. Sometimes it also need to construct the coherent source or monochromatic source up to make a monochromatic to different amplitude, as well as sometime we need microscope cover slip with the holder, gas cell, tapes, digital micrometer, as well as means this source or either source or our helium laser light. This is the apparatus, and as well as uh, other apparatus also needed to conduct this experiment. Next content of my experiment is introduction. The general this introduction of this topics, means this virtual lab belongs to A, B, C, D within different phases, and I'm going to clarify one by one. In A, general this experiment, Michelson interferometer meter will involve the precision measurement on the scale of the wavelength of a light. Note that the refractive index of a helium neon of a given different form, that a vacuum only by 3 parts of Michelson is used to used in his interferometer to establish the first absolute measurement of the length. And when the standard meter was compared with the wavelength of the spectral line of cadmium, the Michelson-Morley experiment using the interferometer was also of the crucial importance in the development of the subject of relative by demonstrating the absence of so-called an ether draft. The first half of this experiment will be performed in the conventional way, using the eye to detect and count the fringe shift. In the second part of this experiment, a more modern version will use a self-contained laser source detector with the photodiode, uh, which output is interfaced to a computer. Michelson believed on the fractional part of fringe facing uh, could be measured 1/10 of the fringe easily, down to 1/15 with care. It's not clear that any of use, means when we counted this fringe, we should precautiously count, otherwise our experiment result could not be reliable. And this is the Michelson interferometer. This is our laser source. Sometime from there we generate the helium neon laser. Sometime we krypton laser. Sometime we generate the ruby laser as our needed. And this is the beam splitter. This beam splitter kept at 45-degree angle with the source, and it helped to split the beam, this single beam, uh, and it transmit the beam uh, from this phase to on the mirror. This is our M1 mirror and this is our M2 mirror, and this single beam which comes from these sources get transmitted in this way and reflected in and finally fall on the mirror M2, and the transmission beam of the light are fall on mirror M1, and after get reflected this beam finally reaches on this beam splitter, and next one transmit reflected beam also reaches on there, means this transmitted uh, beam splitter, and finally these two reflected and transmitted rays combine and they form the constructive or either uh, constructive wavefront or destructive wavefront, and finally this wavefront or this wave fringe are fall on the screen, and these looks like in this form, and this is our micrometer reading which just belongs to or lies to left side of the mirror, and when we adjust the this mirror, means this micrometer, then the mirror, then the position of the mirror gets slightly changed. These all are explained in my this PDF, and these are the form of fringes. These are wave-shaped fringes. These are known as the localized fringe, and these are known as the circular fringe. And now next topics of this experiment means next content of this experiment is our literature review. In this literature review, I mentioned the temporal coherence interference properties of the light are revealed by the single detector intensity measurement in the Michelson-Morley uh, interferometer. Is often described in terms of the classical optics we saw in the pedagogically manner. How such a feature of a light can be understood in term of a more general quantum optics framework. If a thermal reference source is used in MI local oscillator port in combination with the thermal source in the single port, the interference pattern revealed by a single detector intensity measurement shows a distinctive dependence on the difference in the temperature of the two sources. A related method has been used to perform the high precision measurement of the cosmic microwave. Yes, the given experiment is nowadays it is widely used in the field of quantum mechanics also, as well as it is related to the method actually performed to the high precision measurement of a cosmic microwave background radiation. In general, quantum optics framework allows us to consider any initial quantum state. As an example, we consider the interference single photon as a tool to determine the peak of angular frequency of a single photon pulse interfering with a single photon reference pulse. A similar consideration for the laser pulse in terms of the coherence state leads to a different response in the detector. The Michelson-Morley experiment is set up, therefore, an example of the optics device where once in terms of intensity measurement, this is also exhibit the difference between the classical and quantum mechanics of the light. In classical mechanics, we using conventional way to see the this interference pattern of the given light source. But nowadays, this laser or the light emitting diode uh, help to show the different phenomena of the quantum mechanics, uh, which cannot explain our classical physics. And nowadays, quantum mechanical light uh, generate, and it is applicable in the so many field. This concept about which I emphasized. Theory: the Michelson interferometer is a historically important device. It provides a simple interferometric configuration for introducing the basic principle. This device works on the principle of interference. Michelson interferometer can be find out the refractive index of the glass by flowing wave. And this is the theory portion. How can we find out the value of the refractive index? I all I all keep in my this PDF, and this is the way to calculate the refractive index. And finally, after calculate the above mentioned theory, we get this formula. And this is the mainly applicable formula to calculate the refractive index of the glass plate: 2t minus n lambda multiply 1 minus cos theta, where t is the thickness of glass plate, n is the counting number of fringe, such as like as 5, 10, maybe 15, and L is the wavelength of the given source of light, and theta is the angle of a mirror, which I'm going to uh, mention. And after substituting this value in the given relation, we can calculate the refractive index. This Michelson-Morley experiment is also uh, used in the field of medical to imagine techniques, and they are also used in the atmospheric and space application. Methodology. Now I enter on the content of methodology of this experiment. For conducting the virtual experiment, we should precautiously read the all given instruction. After complete this one, then we should enter into the virtual lab. Otherwise, there is too difficult. I face so many problems to conduct this experiment. I already completed 3 experiment, but in this experiment I feel too difficult, too bored, because there are too precaution, there are too precisely measurement. So I feel too hard on these topics. So please, at first we precautiously read the given instruction before we conducting this experiment. Using the combo box, choose later, select the desired laser source means. Now I'm going to show one by one this procedure with the corresponding virtual lab. This is our Amrita virtual lab. To enter in this virtual lab, we mustly type the given address. After typing this address in our virtual lab, we finally reaches in this virtual lab. This is our virtual lab, and the first simulator or the procedure for conducting this virtual lab is just I read in my this using the combo box means. This is our combo box, right? After click on there, we find here 1, 2, 3, 4 different 4 laser light. This is our krypton laser light. This is our helium neon laser light. This is argon laser light, ruby laser light. among the four we should choose anyone, and after that we should follow the instruction which I mentioned, which I emphasized on here, which I written here. Switch on the laser source. After that we switch on, and a bluer fringe pattern will be appear on the screen. These all are I'm going to explain one by one by conducting, by doing the virtual lab. And now I perform experiment with the helium neon laser. So I choose this, and after choosing this, and this is our Michelson Morley interferometer. This is our light source, means laser light source. From there, uh, as our as our choice, means as our choosing the laser light from the given combo box. From there, light source may emit, and this light source at first fall on the splitter, beam splitter. This is known as the beam splitter. This split the beam uh, in two parts. One part of the beam transmitted towards the mirror M1, and one parts of the beam of the mirror reflected to the next one. This is known as M2 mirror. This is our M2 mirror. This is our M1 mirror, and this is the micrometer reading. These reading are known as the perpendicular scale reading. In short, we say that PSR, and this is our horizontal reading. This straight line start with this zero number. This reading is known as our horizontal scale reading as SR, and this is the screen. Uh, Actually, these reading are fall on there. This is our micrometer and microscope. So after zoomed it look like this, and this is our screen where the pattern fringe, constructive or destructive fringe are fall on it, and after zoomed it look like this. Now I'm going to conduct one experiment, means one virtual experiment on the laser light of our helium laser, neon laser. After choosing our laser as our wishes, and second we should click on power button. After click on power button, we look there like this structure. There is a bluer fringe are appear on the screen, and this is our micrometer reading. And from there, at first helium neon laser emitted, and this laser get split from there, and half of the beam reflected toward our mirror M2, and half of the mirror are transmitted toward the mirror M1. And this glass plate, these white small types of the glass plate, this these small types of white glass plate are situated in this portion, and these help to split uh, the single beam of the laser, helium neon laser, into two part. Half of the reflect from here, this beam split to our mirror M2, and half of the portion are transmitted to the mirror M1. This is our micrometer, and after zoom it, we finally uh, pick up the data from this uh, micrometer, and we mainly focus only two parts. This is our on these are this is on the micrometer, and this on the fringes. We only focus on the two part given this and this, and finally we pick up the data and we calculate and we observe, and finally we calculate the wavelength and refractive index of the given laser light. After I'm going to briefing some working principle of this Michelson Morley interferometer. Uh, Before we putting or we kept here our glass plate having different thickness, we should construct our microscope. First we arrange in this way, and after that we should adjust the mirror. We should adjust the mirror because there is a blurred fringe where fringe are often on our screen, so we need a clear fringe on our screen. For that we click on, after click the power button, we click on adjust mirror, and if we move the adjust mirror by the help of our mouse or the forward button on our keyboard, like laptop or maybe from our desktop. There are four up, down, and left, right button already exist on there. You can choose the button either from mouse or from the keyboard. Uh, you can adjust the fringes, and these are the fringe. And if you take this mirror at last corner, means right corner of the this line, then you also found a blur image. And if you make the adjustment at the middle portion of the this line, then you definitely found this well constructive, means clear vision of the fringes. So you can precautiously first adjust the given mirror, and after adjust the mirror, you should also adjust the micrometer, and after adjust the micrometer, you also take the different data on the help of this adjustment. For that, first you click on the given figure, and if you have a like keyboard, first keep one finger on your control button and second on your mouse, and after zoom it, you found these types of the construction, and you can zoom it, and you also make your previous position as your required. And after click on there, and you can see the different movable fringe on your skin as well as the micrometer reading. You only focus on these two parts. First one is our micrometer reading, second is our fringe. And you can start the reading from the central bright fringe to uh, 10 reading towards or outwards, means outward the reading. This is the out to inward reading, and this is our outward reading. If we move on last corner of this adjustment line, then you start from move from there to left side and count the 10 frames. Now I'm going to show one demo for how to count and how to calculate the observation. At first, I'm going to previous stage, which help to do our experiment. Click on this box, then we finally reach our previous position, means initial position. Again, I'm going to click on this 3 dash line, and after adjustment of this mirror, I'm going to count this fringe. At first I keep this micrometer on this place. Anywhere you can make the position of the micrometer, but your center fringe, you can start the count of center fringe from the constructive fringe or either destructive, but minutely keeping the reading, and you also count the reading. It's too difficult in the initial stage. After playing with the so many time with the given virtual lab, you can perform this experiment. Otherwise, it is too difficult to understand. You can also watch the different video into the different like a video maker in our YouTube. Okay, and now I'm going to making this data. First, I'm going to take one simple data. How can we take? First, after complete this three phase, now we enter here and click on here, and after zoom it by clicking on this box, and if we click the control button on our keyboard, and by rolling the mid mouse button, we can see these types of the fringe, but this is not a movable fringe. So for making it movable, we also click on our micrometer, and we also click on our uh, side or forward or backward button onto the keyboard. Uh, you can also move this fringe with the help of this our mouse pointer, but it is too difficult to move the fringe. um, for more facilitate, we have a four button on our desktop keyboard, or either laptop keyboard. Now I make a central bright fringe because it helps to calculate the fringe width. So and I'm going to zoom it, how to calculate. I'm going to demonstrate it. Okay, this is our bright fringe. Look at minutely. This is too difficult to distinguish the other bright fringe. It is it need to clear bright fringe, otherwise our result is worthless. Our time is too consume, and at last we are so feel bored. So please perform this experiment. Before we conduct the experiment, first you look at the center. This is totally need to bright. Okay, and now I'm going to also focus on our micrometer. This is our micrometer. These are known as the perpendicular reading, and these are known as the horizontal reading. Where this horizontal line nearly close to the this line, then this is our perpendicular scale reading, where we uh, put the given this value, coincide value, just like as 0. This is our 0 line, 1 2 3 4. Now the perpendicular reading is 4, and the horizontal reading is 0 1 2 3 4 5 6. This is our horizontal reading. 6 is our horizontal reading. 1 2 3 4. 4 is our perpendicular reading, and these two data we minutely keep or write on our test, in our copy or in our observation. These are the data, and from this data we calculate the refractive index. These are the key data and essential data to find out the wavelength, and after that the refractive index. So at first I think you should know about these two parts. These are the two important things for conducting virtual lab in on these topics. So these are the fringes, and these are the micrometer reading. These reading are known as the perpendicular scale reading. These are known as the horizontal scale reading. And where this horizontal line coincide, we write the value, corresponding value on the perpendicular scale reading. And where the line is, where this circle is meet with the horizontal noted line, then we keep the value as a horizontal line, horizontal scale reading. We keep the value as a horizontal scale reading. Now I'm going to displacement this bright fringe, and for that we enter the or we click or we press the forward key on our keyboard. After one times click, there appear a destructive means dark fringe at the center, and the process is continue, means pressure continuously and precously. And again we found here, I found here bright fringe. This is one count to one means first bright fringe. If you count the first bright fringe one, then this is our two. Similarly, this is our three. This is our four. This is our five. This is our six, seven, 8, 9. If you count this, then your result is worthless. And finally 10. After counting these 10 bright fringe, you should note it down your perpendicular scale reading value. Now your perpendicular scale reading value is 14, and this is your horizontal reading value. Your horizontal reading value is 1, 2, 3, 4, 5, 6. And after picking this value from there, you can note on your note. And similarly, you can also count the 10 bright fringe again. And if you press the forward key on your keyboard, and if you like press the forward key, and there is also change to value on the appear screen as well as in your micrometer reading. Be precautiously, you can do this experiment. And finally, this bright fringe again appear. This is count 1. This is your 2. If you count like these types of bright fringe, then your experiment, your observation, your data will be wrong. 2. This is not 3. This is not. This is also not, because there is a small spot on there. This is 4. This is perfectly dark fringe 4. This is not okay. We precautiously look on the screen. 5. Yeah, this is the perfect bright fringe at the center, and you can only count such kind of the bright fringe. 5, 5, 6, 6, 7. Such kind of perfect bright fringe only you can count, otherwise your experiment result will worthless. 7, 8, 9, 10. This is also wrong counted, okay? Be precautiously look at the center. There is small dark fringe, okay? Yeah, 10. This is the perfect bright fringe at the center. Now look at the again same reading. This is our PSR and this is our EHSR. In PSR, this horizontal line coincide with 30. PSR is 30 millimeter and horizontal division is 1, 2, 3, 4, 5, 6, 6. And where these data are need to write. Now I'm going to showing this one. Okay. And after minimizing this one and yeah, look in this observation table, look on this observation table. Yeah, and now I already written my swimming data in my copy. And before we conduct this experiment, I also write this different column in my copy. So I keep here different records. These records are now going to showing with my, yeah, these are the different record when we make a perpendicular scale reading 2. During that their horizontal scale reading is 0 division. So finally if we write the perpendicular scale reading and horizontal scale reading data on here, and after click on this distance we can automatically found here result. And similarly this one after 10 times count we write these two data, and after again needs to 10 times count we can write this data, and further 10 this data, and this one in this way minimum we should write to 10 times because it makes us precision measurement. And after completely noted down or typing these two data, and after click on their corresponding column we can find the given value. And for calculating this difference means distance difference, we subtract our this 2 from 19, and finally we get 17. We write 17 here, and from this uh, 32 we subtract 19 and we write the coming data on here similarly like other. And we need to one extra data or calculate the given distance. Okay. And after calculating and this data by our levers, we substitute this data on this column, and we take the mean of the given del d means mean of the given data. We adding this all and dividing by 10 because there is the 10 data reading. So finally we get here mean of the given distance, and the mean of the given distance is divided by 10 because we count here 10 bright frames. So finally we get here wavelength of the given light by this formula, by this way. And this is the formula to calculate the refractive index. Now I'm going to show the demo, or I'm going to do the virtual lab to calculate the refractive index. The process is same to calculate the refractive index as previous to our calculation of wavelength. And after adjustment of this micrometer, we should click on here. Yeah, after click on we see here one glass plate. The now we going to find out the refractive index of the glass plate. Okay, so remove the glass plate means glass plate remove from there, and click the place glass plate. Then we will see the glass plate on here, and after that we should choose the different thickness of the glass plate. We have 4 different types of the thickness of glass plate. First one is 1 millimeter, second one is 1.5 millimeter, and the third one is 2 millimeter, and last one is our second last 2.5, and last one is our 3 millimeter. And now I'm going to choose the thickness of a glass plate, which is 1 millimeter. And now I'm going to adjustment of the angle of rotation. Angle of rotation means this glass plate is need to kept on here, and this micrometer is slightly get rotated. So after click on here, this is the angle of rotation. After rotating this means after fluctuating this angle of the given, uh, mm, then we found here different bright frames as which is differ from as our previous. So we precisely do this experiment. At first I'm going to choosing here 2.58 degree angle. Then we found here central bright fringe, either central or dark, it doesn't matter. Okay, and after choosing here different angle, you can choose the different angle and note down its different value on your copy, and you can calculate the refractive index. Now you click on here show result, and finally you can get here refractive index of the given glass plate, which is 1.5. Okay, this in this way, and we can perform other tasks, means we can do the other virtual lab of the to measure the wavelength and refractive index. For that we click on reset, and finally we found the initial stage of our experiment, and we also click on here, and we choose the different laser as our wish, and we can repeat the same process to calculate the this refractive index and wavelength. This is the way of simulator or simulation. And for entering here, I'm try to enter at the previous stage, but before we enter here, we click on their V labs, and after virtual labs, we found the such kind of the topics. After click on these topics, and IIT Bombay virtual lab, you can find here so many different topics, and you can choose the as your need. And today I choose this topics virtual optics lab, or virtual laser optics virtual lab. And after click on there, you can find here so many topics, and I choose this topic, so I click on here, and this is the theory and application apparatus required, aim of the Michelson interferometer refractive index of glass plate. And after read the procedure minutely and precisely to this all, and you can enter into the simulator, and click on here login, and you can choose your Google account. Yeah, I think there is so many times appear the same error result which you just see on my screen. So I already, yeah, you can try so many time, but don't cry, try, okay. And after trying so many times, finally you can found which I perform in my virtual lab, like this. Okay, yeah, sometimes there is so many authorized error may cause to enter the virtual lab, but after so many times you try, you can get these types of the virtual lab. And after uh, entering in our virtual lab, you can do the virtual lab which I mentioned early just now. And finally, we complete this virtual lab simulation. Now I enter in my PDF. These are the data, and I collect this data uh, on my copy, and finally we get these types of the result, and the result are copy or snapping from there and finally kept on here. And next content of my PDF is procedure for real lab. These are the too many procedure. And and the next one is advantage of virtual experiment. It satisfies the scientific passion, such as like our passion today. We are too deserve on this experiment. I really uh, ex- mm, I really experience like I'm not just like as a joke, because this is too satisfaction parts of my life, because I cannot see the like in Michelson interferometer till days, and I cannot able to construct these types of interference in my life. So today I am so happy to get this chance. For this, I want to say special thanks to our HOD sir. Similarly, advantage of other also, it save our time and effort. Sometime it help to consume uh, to our valuable time in our life, save our time. It also record the result electronically. Student can conduct the so many experiment multiple times, and it will help to the student to familiarize with the modern techniques, such as in our department today we are too like too well known about the given these techniques is to conduct this virtual techniques, but we need to remain so many extra knowledge to gain with face our new modern like era. It will help to the student to familiarize with the modern techniques. It enables to display the accurate phenomena. Nowadays, I can see this. I mainly satisfy this sentence because in my experience, I was performed one physical experiment in CDP, Central Department of Physics, which is waste safe, but it is too difficult to see the phenomena like these different ways. But nowadays, I'm so happy to do these types of the web safe experiment in virtual lab. So I want to say the special thanks to our HOD to gives us this golden opportunity and this valuable usage of our leisure time. uh, Limitation, although there are so many advantages, there are some limitation. First one is it is too difficult for performing with to uh, applicable or with uses the different application for conducting this virtual lab. As well as student must have a computer or the desktop. It is a one kind of the challenge for us, because it is economically uh, so cost cost in our locality, means in the context of our Nepal, because we need different like this laptop desktop. It is too costly uh, in our market. Second thing is we need a proper internet connection, and Third one is we cannot get the same confidence such as like our physical laboratory, and physically this practical skill may not be developed. Precaution. These are two important points for conducting this virtual experiment. Uh, these are while taking the reading, no vibration, no noise is nearby surrounding had to be ensured, such as like as fan had to be switched off for physically conducting this experiment. It is too difficult, so it is very precaution. The fringe could appear or disappear as a result of movement of the steel ports. So, so it had to be ensured that steel post was firmly clamped to the rotation platform. Means if we start from bright fringe, then we calmly or we holding the uh, or we firmly claimed the rotation of platform. The starting point of the old reading was taken to be same for each trial. We had to make sure that all lens glass were clean, and there are so many precautions. It is need to minutely read before we conduct the experiment. Result: by using this Michelson interferometer, we calculate the wavelength at first, the helium neon, which is nearly 5430 angstrom, and their corresponding refractive index of the given glass, which is nearly 1.5. And conclusion: the main conclusion of the experiment are at first it is used to calculate or measure the refractive index of a glass, and Michelson interferometer is a historically important device because it is used in quantum physics, also in quantum optics also, and it is used in OCT also, because to imagine the different techniques, and it is also used in atmospheric space application. This is the conclusion of Michelson Morley experiment, and these are the sources, and I mainly pick my data from this PDF from this web address. These are the so many reference, and I mention here appendix. The appendix means I mention here Viva question, some Viva question related to this experiment. First question is, what is the Michelson interferometer used for? The Michelson interferometer and its modification are used in the optical industry for testing lenses and prism. Second one is, what is the working principle of Michelson interferometer? The working principle of Michelson interferometer is division of the amplitude in the form of the extended source, means interference, reflection, principle of interference of light, that is reflection and refraction. Next one, what is the advantage of interferometer? Interferometer was several advantages over the surface of measurement techniques. It has a very high sensitivity to surface topography, typically measured to nanometer. And there are other so many Viva question related to these topics. At last, I would like to express my acknowledge to all faculties, seniors, laboratories, supporting staff, administrative staffs, all my classmates, as well as to whom it may concern, and special thanks to our HOD sir, Central Department of Physics, and other my respected sir, for providing me such a great opportunity to have a unique experience. And at last, not at last, I want to say thank you to all my classmates, my relative friends, my family member, to help me or to support me to make this uh, experiment. And lastly, I want to say Heartily, I want to say special thank to our HOD sir for conducting or for get a chance to familiar with this experiment. Thank you. Have a good time.